Now, in for tutor mark assignment, it is some problems for you to work out on your own and then later submit them to the LMS. Right? All of you do have the access to LMS, right? Learner Management System. Okay, once you take the subject, you will have the access, right? If not, let me know by sending a message or an email. There'll be no Viva in this subject, only two CAT examination, continuous assessment test, and some tutor mark assignments and lab work. For the tutor mark assignment, even though it says two, typically we will give you more than that with small problems. I think the first one you did submit by mid of May, right? And there won't be any extensions, and you must submit through the LMS page. Do not stay until the last minute. This time, we are not going to accept anything other than you submit through the LMS. Because you will find that at the last moment, there will be all sorts of troubles. So better to do it 1 or 2 days earlier than the deadline. Any more questions that you need to know about this subject or generally about studying at Open University? Right, then we will continue with our work. And as I told you earlier, in this subject, we are mainly going to focus about how things move and what causes the motion and how we can control or do the motion as we want. These things will come up in the later years. In this year, what will be mainly focus is what causes the motion and how something move within the space, right? So generally, this subject is consist of two parts, right? One is kinematics, where we discuss and learn about how an object or a particle moves through the space with respect to time, right? So you only worry about the motion, which is called as kinematics, right? In kinematics, what we will encounter is the displacement, velocities, maybe speed, and the different accelerations, right? So you only worried about how an object or a particle moves through space. And the other part of the subject is kinetics. In there, we will see how the motion is generated and how it is kept in a particular way. Right? So generally what we are discussing here is the forces which cause the motion. Right? Now, when you talk about motion, there are various different types of motions, right? So we can divide them for easiness of our study. One way that we can divide the motion is assuming the object that we are considering as a particle. Now, what is a particle? Is something which does not have any dimensions of its own. So it doesn't have a length or a width or a depth. It's just a point in the space. But it does have a weight or a mass. Remember that? In mechanics, when you talk about the particle, it will be a point with a mass. Can you think practical situations where we can assume motion of certain things as a motion of a particle? Real life object, all of them do have a certain size. They do have dimensions, width, length, and a depth. But under certain assumptions, we can consider sometimes a certain thing as a particle. So, can you guess? Can you come up with examples where assuming a particle in motion is a valid option? So, can you tell me a few examples where taking the motion as a particle is not going to affect our outcome of the motion? And what is the advantage of taking something as a particle? Why we need to do it? If not taking it as a particle, it will be a object with certain dimensions. So what are the difficulties you will encounter when you consider something not as a particle? Always we cannot simplify the motion into a motion of a particle, but there are cases where it is a must that we have to consider it as a solid object. But as many as possible times, we try to take it as a particle. Can you see my screen and what I am writing on it? Can you read this? Then what we are discussing is when we can consider something as a particle. Or what is the advantage of taking the motion of a certain thing as a particle? If you take a vehicle, travel in a road, let's suppose it is moving from Kurunagala to Kalam. Can you consider that particular vehicle as a particle motion? Or will there be any errors if we consider it as a particle? Or under what conditions we can take it as a particle? All of you should have traveled from certain town, Colombo, let's say 100 kilometers away place. Is it okay to take the motion as a moment of a particle? Right? So if what you are looking at is the general motion between two cities from A to B, and considering the distance between these two places, right, it may be in 10 or 100 kilometers. In that particular case, the vehicle that you are going to use for the travel can be considered as a particle, right? Because compared to the length or the distance that you travel, the size of your vehicle is negligible. Right? In that case, it is okay to consider this motion as a motion of a particle. But you have to remember that there are certain limitations. If you want a very detailed analysis of the motion of that particular vehicle, suppose you are worried about the vibration, then you cannot consider it as a particle, right? So you are driving a car and you want to consider the vehicle vibrations due to road condition. It will start up and down, it will move sideways, right? When cornering, it has other forces. So if you are worried about that much details, it is not possible to take it as a particle. But if you only worried about how it travels through this distance, then it is okay to consider as a particle, right? Most of the time, as I told you, assuming something to be a particle will give you a very, very simplified version of the problem. If you take it as a solid object, things will be much more complicated. Why is that? What is the difficulties when you move away from the assumption of particle? Now, since particle is a point, that means it can only do translation. That means moving from one point to a different point. So we start from this point and after certain times it will reach another point, right? But if it is a solid object with dimensions, of course it can do the same thing. At one instant it is at this point, and later it moves somewhere here. But what is the difference between a point moving between 2 points and a solid object moving from one place to another place? Now, the point does not have any change in orientation while it is moving from one place to another place, right? Because it is dimensionless. But when you take a solid object, while moving from one place to another place, it can change its orientation or it can rotate, right? It is two dimension, it can only rotate plane. But if it is three dimension, you will see that this is really complicated. It can change its orientation within the space as it is traverse from one place to another place, right? So that is why, as much as possible, we would like to consider a moving object as a particle. Now, when I am talking about these objects, I always say solid object. Are there any things which are not so solid or rigid? Both words are there. They give the same meaning. What that word means? Solid or rigid object. So a particle is a point. Solid or rigid object will have will can show change in orientation, right? And what is this solid or rigid means when it comes to mechanics? Are there any things which are not rigid? If you take a general object, they may not be rigid, right? You can have certain things which moves from place to place. They will rotate, and at the same time, their shape can be changed, right? So the most some things do change their shape. The best example is the fluid motion. Let's suppose water is flowing in a channel. So it is a solid. It do have a certain dimension, right? It moves, it can show rotations at the same time, it can show change in its shape. Other things are like they are like rubber or clay. Those things, when it moves, can change their shape. Right. So remember, general objects do change their shape while moving, change their orientation, and also change the place where they stay with respect to time. When it comes to solid or rigid objects, they only change their orientation and the place, not their shape. And when it comes to a particle, There is no dimensions, but it does have a mass. And at the same time, since there is no dimension, it cannot change its orientation in space from time to time. Right? Any questions from these things? Do you want to ask something? Anything that you do not understand? If you do not have any questions, let's go to the second part. When we go to the motion of particle, we need to understand few basic concepts. Right? Now we are going only about a particle. So that should immediately give you that we are going to talk about the point which moves through the space. It does not have any dimensions of its own, and it has a certain mass. Right? So the first topic will be particle motion. And the particle motion also you can divide it into three categories. One is one-dimensional motion. One have 2D planar motion, and 3D motion. Right? So when a particle do show a motion, the most significant thing is that with time, its position within the space changes. Right? So you can see that at one instant, let's say time t equals 0, the particle is at A, and after certain time, the particle is at B. Now, if you want to know how much it has changed when it goes from A to B with the time difference, we need to know where we measure the change that has happened with the position of the particle. Right? That means we need a coordinate system. So I can come up the coordinate system like this. So this may be x direction, y direction, and this is z direction. Can I mark z in the opposite way to here? Is it allowed to do it? Can I change the orientation of the z axis? How do you know that what I have marked is correct or not? Is it correct? The way I have defined my coordinate system, or the direction of z is in the opposite side. Or you can mark it in any direction you want. Okay, please look into this. Whether my coordinate system is correct or wrong, whether the z direction should be in the opposite side, or you are free to mark it in both directions. Right? So now we have a fixed space in where we can measure the distances. Right? So this coordinate system is not going to change its orientation or the origin of it with time. Remember that it is not a must that you have to define the coordinate system with these restrictions. You can define coordinate systems which change its orientation as well as the point of the origin. Right? Many coordinate systems are there. So it is not a must, but having a fixed coordinate is convenient and easy to handle in most of the cases. Right? So whenever possible, we always use a fixed coordinate system. Then, relative to this coordinate system, the position of point A, let's take it as x1, y1, and z1. And the coordinates of point B, x2, y2, and z2. Right? The things that we are going to consider when it comes to a particle motion is the change of its position, right? From A to B. Right? From A to B, it can travel through various different paths, but that is not what we are going to focus about. The actual change that has occurred between A and B, not the path where it goes from A to B. Right? You can see that you can take a lot of different paths, but ultimately what has happened, it has moved from A to B. This is called as the displacement. Now, displacement is a vector or scalar quantity. Is it a vector or is it a scalar? So if it is a vector, then you need to define the direction, right? So only having a coordinate system is not going to fully define the change happens from A to B because displacement is a vector. Then what else I need? I have the fixed origin. I have three axis. What else we need? Define a vector quantity. Displacement is a vector, yes. Then can we define it only with the coordinates? You cannot do it. We need the unit vectors in each of these axes. So along the x-axis, we have defined a unit vector which is called as or named as I. In y-axis, another unit vector j, and along the z-axis, have k. Right? Now, can I write the displacement which has happened between the motion from A to B? The displacement, typically it is denoted by letter S, is how much? Change in the x direction, x2 minus x1 into I, right? That is direction plus y2 minus y1 into j plus z2 minus z1 into k. Is it correct? That is displacement which has occurred from time t equals 0 to t equals t. Change in the point where our particle lies related to the fixed coordinate system. Then I can define another quantity which is the velocity. So what is velocity? It is the rate of change of the displacement. So how fast the displacement happens. And how we define velocity? We get velocity by taking the time derivative of displacement. So I'm not going to the very basics of definitions with the velocity and displacement and then as differentiation. I think you already know these things. Right? Then we can define another quantity, which is the rate of change in velocity. It's called as the acceleration. And typically it is known by letter A, and this will be E over V2. Now, previously, we wrote this displacement is as at certain time it will be xi, right? So now I can do the differentiation. E over dt xi, right? Then if I write it like this, is it correct? So is this line correct? Can I differentiate this quantity as dx or dt into unit vector I, and this quantity as dy over dt into unit vector j, and this as dz over dt into unit vector k. Is it correct? And typically this dx over dt quantity is write as x dot. Again, this is standard notation, which is called as Newton's notation. Right? I y dot j plus z dot k. So if you ever have quantity with the dot on top of it, that means you have to take the time derivative. That is a standard notation in engineering mechanics. In the same way, we can find the acceleration. So that will be dv over dt. I have x dot I y dot j, and going with the previous argument, d over dt x dot I d over dt y dot j plus d over dt z dot k. And do the same simplification. Dx dot over dti dy dot over dtj dz dot over dt k. And again, the standard notation is x double dot I plus y double dot j plus z double dot k. Right? So what's that mean is related to fixed coordinate system, the velocity, displacement, and the acceleration you can find only by taking the time derivative of change in its coordinates. Right? So the velocity is just x dot, y dot, and z dot. The directions are given by standard unit vectors along x, y, and z. In the same way, acceleration is the second derivative of the position vector. Right? So x double dot into direction I, y double dot direction j, and z double dot into direction k. So anything you want to ask? Let's try to do a simple example of this one. Okay, try this question. It is a very simple question. And to make your work easy, it has only one direction of motion. So there is no need for considering y and z directions. You can take it as a unidirection motion. Simplest case. Try this out. Now, how we can do this question? So it says have a small projectile. That means a moving particle vertically downward into a fluid medium. Let's suppose you have a stone or something which is forced down water, right? In a lake or a pond. And it says that due to the drag resistance of the fluid, the resistance coming from the fluid, this particular particle is going to experience a deceleration of minus 4 to the power v cubic. V is the velocity, right? And you need to find the particle's velocity and position after 4 seconds. So where should we start from? We have given the acceleration. So we can start from the definition for the acceleration. And we have only one direction. So it makes our work much easy. So the acceleration is v over dt. Right? There is no need of the unit vectors because it is unidirectional motion. And this one is how much? Minus 0.4 d power 3. Right? Then what the question asks is velocity after 4 seconds. We know that at time equals 0, velocity is 60. So it asks you when p equals 4, how much is the velocity? Now what we should do? The only equation that we have is this one. It gives us the relationship between acceleration and the velocity. Right? I can write minus 0.4 dq is equals dv over dt, right? Or I can rearrange these terms, which gives me dv over minus 0.4 v2 is dt, right? Now, what you call this equation is an equation, relationship between dv and dt. Call this as a differential equation. Right? To find the solution, what we need to do? We have to integrate both sides. One with respect to v and this side with respect to t. And we have the initial conditions. So t will start from 0 and go up to 4. And v at the beginning it is 60. And after 4 seconds, we don't know the value, let's say. Now, can you do the integration very quickly and apply the initial conditions and find the answer for the velocity? So, what is the integration of this sort? That part you know how to do, right? So, I'll write down the answer. E should be 1 over 60 squared plus 0.8 the minus half. And then find the velocity at time is 4 seconds by applying or substituting t as 4
Sir,
seconds. Then the second part
sir,
of the question asks you to find the displacement. How we can find displacement? No, v is ds over dt. And we have found the velocity as 1 over 60 squared and we can do the same thing like in this case. So we have ds as We can integrate to find the solution. S will be from 0 to S, V is from 0 to 48 out of B, and then we can calculate 4. Integration and differentiation you already done, right? Was in this subject, we will be learning about the engineering mechanics or necessary maths knowledge you have to get either from your A-levels or I think you have two math subjects from there. So be focused with differentiation, then integration, then vectors, and also differential equations. Those are the things that you will need for this subject. There are a few more examples or a few more problems in your assignment. Try to do them. And if there is time on the next day school, I try to do more examples from the particle motion. Now, let's see if it is possible to define the motion of a particle using slightly different coordinate system. Right? So, is there any other possible way to define the coordinates? What we have done is using Cartesian coordinates. What is the other definition that you can come across? Is the polar coordinates. This also we can use. Define a motion of a particle in space. What polar coordinates? We will only focus on a plane. So we are not going to use the cylindrical polar coordinates or the spherical polar coordinate, which is used to define system in three-dimensional space. Right? So our analysis will be only on planar motion. So now again, I am going to do the same thing. I will have a particle which will move in space. So at one time, it is at T1, and the next time it is at T2. Right? Now I am going to use polar coordinates. In polar coordinates, you need an origin, a fixed point. And how are we going to define a point in space when you have polar coordinates? What are the things that you will need? In Cartesian system, you use the distances in x-axis and the distances in y-axis. But in polar coordinates, what we use? We are going to define it by distance between the fixed point and the point we are considering r, and the angle from starting point. So r1, theta 1. Right? And these points will be r2, theta 2. So have you done polar coordinates? You should. Is there anything that you cannot remember or any difficulty? This one? Right. There is no question. We can proceed. So, in general, can define a point is along the path of this curve as and theta. Right. Now again, we come to the same problem. The displacement is a vector quantity, right? Position of the particle at certain time with this p must be given as a vector. And this r is the distance between the origin and the point. So how can I define a vector quantity for this particular case? So we have the path. In the path, we have point is p given by r and theta. Here is my origin. Now the problem is how to define the position of point P as a vector. From the previous case, where we have the Cartesian coordinates, we use something called as the unit vectors. Now in this case, how we can define unit vectors? Because we do not have the axes like x and y which we had in the previous case. There is no coordinate axis. You have the origin, you have distance between origin and the point, which is r, and you have the angle theta. Since in the polar coordinates, you always measure the distance from the origin, the point, as r. I can define one unit vector along the O and P line, OP line, which is in the direction of where you are showing the R. And typically this is given as E R hat, right? Unit vector along the R direction. Now, if you have one vector in R direction, must define the other one perpendicular to this. And this vector, unit vector, is called as theta, right? Just like in the previous case, where you have x1, y, and the direction unit vectors I and j. Here you have a vector which is along O and P line R is given as ER and one perpendicular that E theta. Right? So ER is a unique vector along the R direction. E theta is a unique vector along the perpendicular direction. So radial and tangential directions. Now I can define the displacement S a vector as r, which is the length, into the direction er, right? From displacement is r into the direction er. Then, from our previous definition, we can find the velocity as time derivative of displacement. That means d r er into dt. Which gives me is this correct? If I write it in this way, is it correct or is something missing? So what is missing in this one? Or dRO dt is there. You can see dRO dt into ER. Okay, dER over dt. So how to find that? You want to see this part. Isn't that zero? Well, VER is a unit vector. It is zero, right? Is it zero or does it have a value? So how to know whether it is zero or non-zero? You only need to check whether this D or this ER vector does depend on time or not, right? When you take the previous case, unit vectors ijk, they do not depend on time. So there is no differentiation with respect to time. But when you look at how we define this ER vector, you can see that it is oriented always along OP line. That means when the particle moves, this point P is going to change. And one time it is here, next time it will somewhere here. When point P change, the OP line changes. Right? If the OP line changes, so as the vector ER, because it is always defined along line OP. When line OP change with time, the vector ER does change. That means this ER, when you differentiate with respect to time, is not zero. So it must be in this way. Now, how we can differentiate a vector? That is the big problem. So it is not zero for sure. Then how to find this quantity DER over dt? Is there a way to get this value? Or you can do with several different definitions, but the easiest is to look at how these polar coordinates are related to Cartesian coordinates. Right? That is the easiest thing that you can come. So if I place Cartesian coordinates and the polar coordinates on the same system, in x direction you have the unit vector which is called as I, and in y direction you have the unit vector called as j. Right? Now on the same one, on top of this, I am going to mark the ER vector. This is ER and ET. Now remember that all of these are unique vectors. Right? Then I can get the projections of ER onto I direction and to J direction. The angle is theta. This height will be sine theta. Actually, it is 1 sine theta because this length is 1. We don't need the 1 here. And this will be cos theta. Right? So here, the vector, I can write this as cos theta I plus sine theta j. Right? From this one. So the length is 1. So this side should be cos theta into I. And this side should be sine theta into j. So here, vector is nothing else but the addition of cos theta I plus sine theta j. Right? In the same way, I can find this E theta vector, which is minus sine theta I plus cos theta j. Right? It is simple geometry and trigonometry. Just see the angles and take the components in I and j directions. Right? Any difficulties on how we get these two values? Right. Now, do the differentiation of ER. TER dt is E over dt cos theta I plus sine theta j. And I and j are fixed unit vectors. You will not have di over dt continuous. G0. That means only have the differentiation of cos theta is sine theta minus then the differentiation of theta d theta over dt into I. And this part, differentiation of sine theta is cos theta. Then the differentiation of theta, and again into vector j. And di and dj are not going to exist. They are fixed vectors. So differentiation of di over dt and dj over dt is 0. Then what we have here? Theta dot minus sine theta I plus cos theta j. What is this quantity? This is E theta. So that means differentiation of ER vector is time derivative of the angle theta dot into direction of E theta. Right? Even though it is not needed for the velocity, you will later need it. Let's find the other one, which is d E theta over dt. This you will get as minus theta dot er. Check whether this quantity is correct or wrong. Now the velocity in polar coordinates, I can write as dr dt er plus r er over dt is theta dot e theta. It means r dot er plus r theta dot e theta. That is why at the beginning I told you the coordinates that we use can be changed with respect to time. Right? It is not a must to have coordinates and unit vectors fixed in time. Of course, in Cartesian coordinate, you get it as fixed vectors, but in polar coordinates, comes as the moving coordinate system. And especially in some cases where you have the tangential velocities or the rotation around points, you will see that the definition of this polar coordinate system is much, much more convenient than this Cartesian coordinate. Now the next part is to find the acceleration, which will be dv over dt. So what we have d r dot dr plus r theta dot d theta. So try to find the acceleration using polar coordinates. Plus this one dr dot over dt into er plus r dot er over dt and here plus r theta dot dg theta over dt plus r d theta dot over dt d theta plus er over dt theta dot d theta. And then dr dot over dt is the Newton's notation r double into er plus dr over dt is what? Theta dot d theta, right? R dot theta dot d theta. Then r theta dot d theta over dt. So d theta over dt we found as minus theta dot er. The minus r theta dot square er plus d theta dot over dt is theta double dot r theta double dot theta plus this will be r dot theta dot dt. Then we have in r terms and in theta terms, you can separate them. R double dot minus r theta dot squared er plus r theta double dot plus 2 times r dot theta dot so this is the radial velocity and this is the tangential velocity, tangential direction. But in reality, the four terms do have four different names. So this component where you have the second derivative of radial direction is called as the radial acceleration. This is radial acceleration. This quantity where you have r theta dot squared minus this you already know from the circular motion or motion in circle. This is the centrifugal acceleration. And this one, you have radius times the theta double dot term is the tangential or radial acceleration. And the last component, where you have the multiplication of the linear velocity and the angular velocity, is called as the Coriolis acceleration. Right? So in polar coordinates, the acceleration acting on a German particle moves plane. We have four different components. Two in the radial direction and two in tangential direction. Radial one, yeah, you have the second derivative of radius is the radial acceleration. Second part, In the centrifugal acceleration, this one you already know from the circular motion. Then the tangential, what we have from the radial, this angular acceleration or tangential. Right? Angular tangential acceleration. And the last part is the Coriolis acceleration. Right? Any question from these things? Or anything else that you want to ask about the subject or your PMA1? Or about the first continuous assessment test? Because you don't have that much time. First CAT exam will be on the first book. You need to be thorough with all the sections in the first book. And remember what I told you, subject is not that easy. So you have to start working from today onwards. For the TMA, no, there is no layout. Just have the standard format of our page with your name and details, and then the given purpose. Then scan it and upload to the LMS. Only thing is that our LMS only accepts files with size less than 5 MB. So this is the first lecture. As I told you, we have only like 3 or 4 day school for the whole years. So most of the time it is up to you to work on your own. Right? I can have more questions. Actually, this 4 day schools is not enough for the subject, so we will have a little bit more questions. But still, it is up to you to work. Right? It is really good if you can come well prepared for the day schools. Then I can discuss very quickly, go through the questions you have and answer it. Right? It is not like in a conventional university where you will be having lectures each and every week. And previous years, even if you are slightly short of eligibility mark, hoping that you will do well in the finals, we typically let you do the exam. But starting from this year, even if you get 39, you are not allowed to sit for the exam. Right? It's very strict. You must get passed through the eligibility mark. And especially remember, if you get less mark for the CAT exams, it will be really hard to be eligible. Because 70 marks goes for the full CAT exam. You get only 10 marks for both of them. Believe me, you will not be able to sit for the last exam. So do the EMS that will greatly help you in the CAT examination. So you need to study it through the textbooks and get the knowledge from them. That will help you do the EMA assignment and also with your CAT examinations. So if you do not have any questions, we can wind up the session for today. Let's try to have one or more questions for your CAT exam.